Howdy, howdy, my favorite calculates. So today we're going to look at limits as x goes to infinity. In other words, probably looking at some horizontal asymptotes. And I talked to you a little bit about this as they have occurred, but when I'm looking at limits as I'm going to infinity, I'm really looking at end behaviors. And so I want to know what's happening to the y values as x goes to either positive or negative infinity. And you've had horizontal asymptotes in the past, so those are not a new concept. So if I was graphing this, of course, I'd want to know where the x-intercepts were, and I can find that by setting y equal to 0, and of course solving. But if y is 0, really I only need to look at the numerator, because the denominator will poof if I cross multiply or multiply both sides by the denominator. So really, I don't need to worry about this. A fraction is only equal to 0 when the numerator is 0, which means x is 0. So I have an x-intercept on the origin. And then when I'm looking for the vertical asymptote, I would set that denominator equal to 0. And so I'm going to get x squared equals negative 1. Of course, that's a no solution. And if I want to know the horizontal asymptote, I'll look at the degree of the numerator and the degree of the denominator, and then if I need to, I'll go back and look at my notes for chapter P about the rules for horizontals. If they are the same, then I use leading coefficient over leading coefficient. So I'm going to get y equals 3. So I'm going to dot that in, and then I'll start to pick some points around this x equals 0. If I plug in 1, I get 3 halves. And negative 1 would get me the same thing. And if I plug in 2, I'll get 12 fifths, which is 2 and 2 fifths. And same thing for negative. And so what it's doing is approaching that horizontal asymptote from the bottom. So in this particular case, as x approaches positive infinity, then y is approaching 3. And same thing over here, as x is approaching negative infinity, y is approaching 3. So by definition now, a horizontal asymptote is whatever we come up with y equals if the limit as x approaches positive infinity for my function is L, and the limit as x approaches negative infinity is also L. So really, it does not matter, and I think I talked to you about this before, what's going on in the middle of the graph. As a matter of fact, I might actually have a couple of vertical asymptotes, and I could, in fact, cross over the horizontal asymptote. Let's say that the horizontal happened to be the x-axis. I could cross it in the center, but what can't happen is I can't cross it out here as I'm going to infinity, and I can't cross it out here as I'm going to negative infinity. That's the definition. So the reality is I could literally erase that green line here in the middle. It doesn't really affect the middle anyways. It's only really referring to the actual tails of my graph. Okay, I'm going to erase all that. And so that means that my function can have at most 2 horizontal asymptotes. They could be on different levels. So maybe I have something crazy like this going on, where positive infinity is approaching this one and negative infinity is approaching this one. And since I'm about to run out of video, I'll talk about the next theorem on the next video.